Today we will be discussing about the parallel distributed processing approach of memory. This model differs from the other models because it does not focus on the distinctions among the different kinds of memory. Instead, in this approach, the cognitive processes are represented in the model in which the activation flows through network that links together neuron-like units. The parallel distributed processing approach is often abbreviated the PDP approach. In this theory, for retrieval of information, two different search strategies are proposed. A serial search, that means the items in memory are somehow ordered and are examined one at a time, starting with the first item and proceeding to the next. Next is a parallel search in contrast to the serial search. That means that all items in the memory are examined simultaneously and not serially. Like in the first place, when I was discussing serial search, I said it's searching one item at a time. And in parallel search, we are searching various items simultaneously. Obviously, when the amount of information that must be searched is large, as is the case with the long-term memory, a parallel search process will result in much more efficient retrieval of information for the obvious reason because there is a large body of knowledge, large body of information in the long-term memory. So if we are to do a serial search one item at a time, then it will take a lot more time. So in that case, we will be doing or we apply or cognitively a parallel search. Another distinction concerns when the search terminates. A self-terminating search refers to the one that stops as soon as the item being sought is found. In contrast, an exhaustive search refers to one that continues to examine all items in the memory even after the target item has been found. Sternberg demonstrated that retrieval from STM involves a serial exhaustive search, but in LTM, where there are millions of items to search, a serial exhaustive search could be highly maladaptive. So, obviously, how the search terminates when it's a serial search, it's like if I've got when I'm searching and I've got what I want, but still I'll go on searching with all the items. But this is not in case for the parallel search. In parallel search, as I'm searching all the items together, whenever I reach my target point, my target thing that I was searching for in the memory, the search system stops. Now, this theory, James McClelland is one of the major developers of PDP approach, that is this theory, and he described how our knowledge about a group of individuals might be stored by connections that link these people with their personal characteristics. According to PDP approach, each individual's characteristics are connected in a mutually excitatory network. If the connections among the characteristics are well established through extensive practice, then an appropriate clue allows us to locate the characteristics of the specific individual. Now, with many important discoveries in neuroscience, it has become evident that there exist numerous interconnections among the neurons. Many cognitive processes are now believed to be distributed over a section of the brain. This involves parallel processing with many signals handled at the same time. Thus, processing appears to be both parallel and distributed. In PDP, that is parallel distributed processing approach, neural networks are thought to work in parallel to change neural connections to store memories. This theory also states that memory is stored by modifying the strength of the connections between the neural units. Neurons fired together frequently, which occurs when particular behavior or mental process is engaged many times. They have stronger connections between them. If these neurons stop interacting, the strength weakens. So neural networks play important role in memory. Now, one advantage of PDP model is that it allows us to explain how human memory can help us when some information is missing. Specifically, people can make a spontaneous generalization which involves making inferences about general information that they never learned in the first place. Default assignment is used in filling the missing informations about the particular person or the object or the information that is being searched for, and thus the searched item is obtained. Now, many a times people confuse in between spontaneous generalization and default assignment. But remember that spontaneous generalization involves making a judgment about a general category, whereas default assignment involves making a judgment about a specific member of a category. That is, if I am talking something about engineering students, it is a general spontaneous generalization, it is a general idea that I get from the engineering students. But if I'm talking about specifically about one engineering student or one psychology students, then like these are the system of psychology students, or these are the characteristics of psychology students that we generally presume. So this kind of thing that we presume is like used for the generalization, the spontaneous generalization. And if I ask for a specific one in the psychology students, like if I talk somebody named Onkita in psychology student, now do you know that girl Onkita, psychology student? So when I'm talking something about, and I'm filling the missing informations about that typical person, then that is actually default assignment. Okay, so this is the general idea, the concept of the PDP approach. Now, if we just bullet or we order the characteristics, the general characteristics of the PDP approach, then we might do it in this way. Like number one, a network contains basic neuron like units or nodes which are connected together so that specific unit has many links to other units. Hence, alternate name for the theory, connectionism, because this theory is also called or named connectionism. Then the second point is the connections between these neuron-like units are weighted, and the connection weights determine how much activation one unit can pass on to another unit. Then number 3, when a unit reaches a critical level of activation, it may affect another unit either by exciting it if the connection weight is positive, or by inhibiting it if the connection weight is negative. Then number 4, cognitive processes are based on parallel operations rather than serial operations. Therefore, many patterns of activation may be proceeding simultaneously. Then another point is knowledge is stored in association of connections among the basic units. And in this view, this is very different from the common sense idea that all the information we have about anything, a particular thing or object in one space is located in one specific location of the brain. In fact, the term distributed processing suggests that the knowledge is distributed across many locations in the brain. Then next is every new event changes the strength of connections among relevant units by adjusting the connection weights. As a consequence, we are likely to respond differently the next time when we experience a similar event. So our different reactions in similar event can also be explained by this approach. And lastly, another characteristics is sometimes we have a partial memory for some information rather than a complete or perfect memory. But the brain's ability to provide this partial memory is called a graceful degradation. So this approach, parallel and distributed processing approach, is quite different from all other approaches that we all have discussed, because all of them have discussed about the various storage systems, how to store informations and like that. But in this case we are not talking about the storage system, but how this memory can be formed, and in the way of neural connections, and how processing parallel and how we search in the memory, the informations that we search in the memory, that all is explained by this approach. So this is all about parallel distributed processing approach, or PDP approach. If you have any doubts regarding this, you can comment in my classroom or in my doubt clearing class. Thank you, class.